Hello, good morning. I am M. Hafizur Rahman. Today I am going to discuss about a very important topic for the computer science. Especially it is very important for the computer hardware, which is the logic, computer logic or logic circuit. And today's content is only the combinational logic. Basically, a logic circuit is composed of couple of input which will produce a couple of output using some functional and timing specification. And for example, here this is a logic circuit which has three input A, B and C, will produce two output Y and G using three circuit element E1, E2 and E3. Those circuit element is connected from the input to the output using some node. Here in this circuit, in this logic circuit, there are 6 nodes. Out of this 6 node, one node is internal node N1, which is connecting the circuit element E1 to the E3. So there are two types of logic circuit. One is combinational logic, second one is sequential logic. For the combinational logic, outputs are determined by the current values of the input, meaning that we don't need to consider what was happened in the previous time. So we don't need to remember the values of the previous time. So no need to no memory is used here. It is memoryless. But sequential circuit, outputs determined not only by the current values of the input, but also we need the previous value, meaning that we have to remember what was happened in the previous time or previous clock pulse. So meaning that we need some memory. In this sequential logic we have memory. For the combinational composition, every circuit element is combinational, and every node is either an input node or connect exactly to one output node. This circuit contains no cyclic path, only the feed forward path is used here. Here is an example of a combinational logic or combinational circuit which is composed of two AND gate and one OR gate. There is some example of the Boolean function here. The functional specification of input in terms output in terms of the input. There is two Boolean function, S and C out. S is a function. This is the combinational logic, and this black box basically represent a full adder which has three input A, B and C input, and will produce two output S and C out. S and C out. So the output S, which is a suffix of short form of the sum, is equal to the function of input variables A, B and C in. Output carry C out is equal to also a function of A, B and C in. After deriving the truth table of the full adder and simplification, we found that the function S is equal to A exclusive or B exclusive or C in. C out is equal to A and B or A and C in or B and C in, or you can call it AB plus AC in plus BC in. Here is some definition which is used for the logic implementation or logic circuit implementation. One is the literal. Literal is basically the English alphabet letter is used A, B, C. Sometimes the complement of this literal is also complement of this letter is used. For example, the variable with a bar over it is called the complement. A bar, B bar, C bar. A bar, B bar, C bar. This A bar is the complement of A, B bar is the complement of B, C bar is the complement of C. So both the normal variable and the complement of that variable are called the literal, and the product of those literal is called the implicant. For example, here three example here: A, B, C bar, A bar, C, B, C. These are three literal, and there is two term. One is called min term, second one is called max term. product minterm is a product that includes all input variables. Similarly, maxterm is a sum that includes all input variables. So there are two types of implementation. One is sum of product. The name itself gives you the definition. It is sum of product. First you will have a couple of product, and then you need to add those product by summation. So other way around, you can call it, you will have sum and term, then you need to OR those and term. So any Boolean function can be written in sum of product form. So each row of the truth table has a minterm, and a minterm is the product of all literal. For example, here you have two input variable here, a, b, and one output here, y, and for the binary combination here is equal to 0, 0, 0, 1, 1, 0, 1, 1. For the minterm, the 0 means the complement of that input, 1 means the normal variable. So it is that a bar, b bar, a bar and b bar, a bar and b, a and b bar, a and b. You have 4 minterm, and normally these minterms are represented by the small m, with the suffix 0, 1, 2, 3. Basically this suffix are the decimal equivalent of those binary combination. So in this one, out of this 4 minterm, out of this 4 combination or this 4 minterm 1 and minterm 3 produce you the yield you the output is equal to true, which is equal to 1, which is equal to 1. So each minterm is true for that particular row. Okay, so this is that we have to consider this minterm and this minterm, this product and this product, and then we need to add those two products. So it is that we have to, this product is a bar b and second product is ab. We need to add it. This is called the product and this is the sum, and in total this is called sum of product implementation, and it is represented by the summation sign. Symbol is the summation, and this 1 and 3 is the minterm number 1 and the minterm 3 here. Second one is the product of sum form. Basically it is the opposite of sum of product. It is the same here, that any Boolean function can be represented, can be written as a product of sum form, and every row has a max term, and max term is the sum of literal, or you can call it OR of literal. So you have, if you consider the same truth table here, a, b and y, you have the 4 combination 0, 0, 0, 1, 1, 0, 1, 1, and you have here that normally in the max term 0 represents the normal variable and 1 represents the complement of that literal. So this is 0 and 0, this is also 0. So this is that a or b, or a plus b, it is a sum. This one is a plus b bar, this is a bar plus b, this is a bar plus b bar. These are the 4 max term, and max term is represented by capital M. Similarly with the suffixes, and the suffix are the decimal equivalent of those binary number here, and those binary number here. Out of this 4 max term, 2 max term produce the output which is the false. So we have to consider those false output for the product of sum implementation. So it is that output function y is equal to function of a and b, and it is the sum. One sum is equal to that a or b, and second sum is equal to a bar or b. We need to do the product, we need to do the AND operation here, and it is represented by the big pi here, and inside the bracket there is 2 max term. Max term is 0 here and the max term 2 here. This is that 0 and this is that 2. Okay, so let's have a look at real example. Suppose that end of the class you will have your lunch time and you would like to go to the cafeteria to have your lunch, but you want to eat your lunch. This E is for eat, and E bar is that not eat. You don't want to eat the lunch. Well, if the cafeteria is not open, definitely if it is not open, there is no way for you to have the lunch there. So O for open and O bar meaning that not open, and you don't want to take your lunch if the cafeteria serve only the corn dog. So it is that C for corn dog and C bar is not corn dog. So you have the 4 combination as before: 0 0 0 1 1 0 1 1 and 1 output E for eat. Whether you will eat or not eat will be decided depending upon the binary value here as mentioned here. So these first two 0 and 0 meaning that the cafeteria is closed, no way to have the lunch there. So it is 0 here, this is 0 here. This one and this one meaning that the cafeteria is open and you have to consider the menu. This menu is, you have the corn dog and you have other than the corn dog. So if you have the corn dog, it is your dislike, you don't like it, that's why you don't want to have the lunch there. So it is 0 here, and it is 0 means that other than the corn dog, the other menu is available there, so you would like to have your lunch in the cafeteria. So this is the truth table of this scenario. In this truth table, you have 4 min term and 4 max term. Out of this 4 min term, 1 min term, this one will give you the output, true output, and 3 max term 0 0 0 will give you the 0 output or false output. For the sum of product implementation, you have to consider that min term, and that min term is equal to OC bar, which give you the result is equal to 1. This is that OC bar, and this is the summation, sum of product, and you need to consider only one product. That product is the decimal equivalent, the min term number 2. And for the product of sum implementation, you have 3 false output, this, and this. So you have to consider this, and this. So this is the big pi of 3 max term, 0, 1 and 3. This is the 0, 1 and 3. And for the max term here is equal to O or C. This one is O or C bar. This is O bar, C bar. So these are the basically your this bar will be here. Basically this bar will be here. This is that. Again you have the max term 0, 1, 3. This is 0, this is 1, this is 3, and the max term here is O or C. Second one is O or C bar. Third one is equal to here O bar or C bar. So these are the 3 sum. You need to do the product of those sum, and it is the product